Hi, I'm Rodney Dowdle, and I am the VP of R&D for TeleCANesis. Today I'm going to show you our new product, version 1.0 of TeleCANesis. It's a product that helps you to define messages and data and have it routed to different spots. Basically a universal data routing system. So I'm logging in here with my account. I can create what we call as a blueprint. I have to give it a title, so I'll just call it Embedded World North America. Create the blueprint. What we've done is we've broken this idea of blueprints into capsules and devices. Systems are becoming more interconnected as they get more complex over the years. So a device is something that's connected to the capsule, so something that's like a CAN device or a GPIO device. And that would be connected to your capsule. Your capsule is basically your OS in combination with your hardware. So we'll pick something like Linux. And this Linux version is a Cortex A53 running Yocto Kirkstone. The version number is 1.0 for our release, but it's the version of the middleware that's going to be running on the capsule. So as we release more versions, you could change and switch between them depending on what you may need.
So at what step of the development do your customers use your tool?
In the beginning, very early on. Because what you're trying to do is figure out how the messages are going to flow through the systems and connect to one another. So that needs to be defined early on so that you know what you're reacting to at other parts of the development stage.
So before you develop a system, you start here?
You start here, yeah. You'd map it out to have a thought process of where things are going to go. For example, if we were using CAN in the system, you'd want to know what sort of messages are going to come in on the CAN device. So this is usually defined through what is called a DBC file. So you would create a CAN decoder, and we'll just call it CAN, and you would upload a DBC file. Say you have an electric car master DBC file. The system parses all the messages that are in that DBC file and adds them to the engine. The engine is now aware of those messages that are going to be coming in off of the CAN device. And from here, you can start to plan out what each of these messages would mean in the context of your UI or your database or your web page as they correspond to what's happening within the vehicle or the device that is producing those messages.
So your UI is very cool. Is it important to visualize a vision of what the device should do?
Yeah, so one of the challenges we have as these systems become more complex is we don't really, we may not be able to fully keep in our head all the things that are going on within our systems. What's going to your Android phone? What's going to the HMI that's displayed in your car or your side-by-side vehicle or whatever, right? So tracking where messages are going and where data is going is becoming more and more important because maybe you don't want all the messages to go here, you only want a subset of them, and then you want these other messages to go over there. The next step after that is even like state planning. What happens when you get this message? What happens when this message has a value of 2 or a value of 1? That's the next step in the evolution of this product.
You talk about messages, so it's like all these different components are talking to each other?
Yeah, exactly. So, messages are a way of triggering events from happening on the device, right? You open your car door, you lock your car, that generates a signal or what we're calling a message, and that gets sent through the system to somewhere, and somebody has to respond to it.
Is there different bandwidth for different kind of messages?
Yep, yeah, definitely. So, CAN has a certain bandwidth to it, usually about 500, a baud rate about 500 kilobauds, is it, I think? Something along that. And then, MQTT is transmitting over the network, so it's going to have a much faster transmission rate. So,
and what's so important about visualizing or planning out the data, where it goes? Why is it so important?
So it's important in the development process because what happens is when you don't do this, you start to get mismatches in data at certain parts. So your HMI may not fully understand what it needs to respond to because it just was never planned out. So when you're writing that code or you're a developer in that space, you have to know what is expected of you. And if you don't know the data that's coming in, you don't know what's expecting. You don't know what that data representation is, you don't know how to respond to it. So if you don't have that planned out early enough on, it makes your architecture sort of start to fall down. It makes it harder to sort of interact with each other.
And you say it's version 1.0?
Yep.
So your customers been waiting for this to come out, or?
Yeah, so we've been working with some customers behind the scenes while we build this product up. They've been sort of feeding us information that says, hey, you should do this, you should do that, so that we can make a product that actually suits our customers' needs. So we've been going through that, and a couple customers like the OI Dragonfire here, TeleCANesis runs on that today, and it's used, because this is used in automotive adjacent products such as side-by-sides or watercraft vehicles. What happens is they'll need to hook into CAN buses from different systems, and with using TeleCANesis, they can quickly get the UI up and running, hooked into those CAN devices.
So is this, would you say, revolutionary for the industry, or?
Well, that's an interesting thing. The way we've approached it, I think, is revolutionary. I mean, the data routing and conversion stuff is not, over the top, amazing or anything like that. Like, it's something that you can do. In fact, a lot of people do it today. It's just, if anything, it's kind of the boring part of the development lifecycle. Like, figuring out how I'm going to convert this CAN message into a JSON thing is not sexy, for lack of a better term, right? Most people like to look at the back-end business logic and what I'm going to do with the data. So what we've done is this approach of being able to just sort of describe the data and describe your system at a high level. That's the revolutionary piece. The part, where we actually generate the config file and run it inside the middleware, not so much, right? So that one is more of we need to have some middleware there to kind of react to what we've done at the higher level.
So what's the feature request or the roadmap? Like, what's going to be in 1.1 or 2.0?
So as we move forward, one big thing that we're looking at for 2.0 is safety certification for our middleware, so that it can be used in safety critical systems. So that's a big one. We're also looking at introducing sort of a state management system as well, where you can pick and choose what the different values mean and what should be triggered when a certain value comes in. Extensive protocol support for stuff like JS 1939, EtherCAT, and a couple other protocols that we've sort of discovered. So just expanding on what we've already currently got from a plugin sense, and then maybe adding in a few extra tools to our tool package to allow for a more complete subset of stuff.
And what would be some examples of competitors in this kind of industry, and how would you say you are doing stuff in a better way?
So this is actually an interesting thing. I don't think we have a direct competitor for what we're doing right now. We have what we call micro competitors. There's a lot of people out there that have done things that are that have done pieces of what we've done, but we kind of fit either on this side of them or this side of them and complete the story for them. So we're kind of in competition in some aspects, but in a weird way, we can actually extend what they want to do with our tooling so that we can offer a more complete solution for them. So,
and it's just on the web?
This is on the web. So if you go to hub.telecanesis.com or just telecanesis.com, you can get to our product.
And it says builder, tooling, library.
And support.
All right. Could you use AI to do even more cool stuff?
Exactly. So this is actually so when you talk about 2.0, maybe not 2.0, then when you said what's on the roadmap, using AI to look at an existing project and pull the messages out of what's in that project is something that we're planning to do at some point. So it'd be an ingestion method for how to set up your data.
Could the AI help also to get the boring parts even less boring?
Yes, exactly. Yeah.
Right.
So you.
Don't get fooled by fake HDMI products. Only source authentic HDMI products from licensed HDMI adopters and authorized manufacturers and
resellers to ensure compliance. Counterfeit or unlicensed products can cause poor performance.
Certified HDMI products undergo official testing for safety and spec compliance.
Avoid brand damage, warranty issues, and customer dissatisfaction from unlicensed products.
Long-term cost savings come from reliable, genuine HDMI solutions.
Unlicensed products may lack support and pose safety risks.
Use certified HDMI cables with official HDMI certification labels.
Report suspected counterfeit products at hdmi.org/resource/infringe.
Thanks to our global partners for helping keep the HDMI brand real and ensuring consumers get the experience they deserve.